Today we are looking at this one of the most important limits in calculus. This limit appears everywhere, especially when differentiating trigonometric functions. Let's build a simple geometric picture to see why it's true. Start by imagining a small angle x measured in radians. From this angle, draw a right triangle. Let the base be equal to r. Now in this triangle, the opposite side is BC and the adjacent side is AB equal to r. From the property of tan x, we see that the height becomes r tan x. So the area of this triangle is half times base, that is r, times height r tan x, that is half r square tan x. Now we take point A as the center and draw a circle with the same radius r. This circle intersects the hypotenuse at the point D. The sector formed by the angle x fits inside the triangle, so its area must be smaller than the original bigger triangle. Since full angle 2 pi covers the entire area of the circle pi r square, so 1 radian covers r square by 2. That means x radian covers half r square x, which is area of the sector. Next we join points B and D to form another triangle inside the sector. To find its area, we drop a perpendicular from D to the base. In that small triangle as shown, sin x is equal to dE upon r. So the height of this triangle becomes r sin x. This gives the inner circle area as half times base times height, that is half r sin x, half r square sin x. Now we have three shapes: the big triangle, inside that the sector, and inside that the small triangle. So the areas follows this inequality. Now dividing throughout by half r square being the common factor, we get tan x is greater than x is greater than sin x. Now dividing by sin x, we get cos x is less than sin x over x is less than 1. Now we take limits. As x approaches 0, cos x approaches 1, because cos 0 is 1. The right side is already 1. So the expression in the middle gets squeezed between these two values, that both becoming 1. So by the squeeze theorem or the sandwich theorem, the limit of the middle expression must be 1. And that's the fantastic geometric proof. If you like the presentation, please like the video and subscribe the channel.